Hello everyone, welcome back to another Sci-Friday. This one specifically we're going to call Sci-Freeze-Day because we're going to be talking a lot about cold and how the cold works and how ice kind of works. And so we're going to do a few experiments where we're going to deal with ice and one of them with a little bit of liquid nitrogen. And so we're going to go ahead and get started with our experiments if you're ready, Steve. So our first experiment we're going to do today is we're going to do the experiment which deals with how do we melt ice most efficiently? Like what's the best way to melt ice? So we're going to work and figure that out by doing a couple of experiments, and we're going to get started with that in just 1 second here. So our first experiment we're going to do is we're going to test two different kinds of water to see if one helps melt better than the other. So the two kinds of water we're going to use are temperature room water and then hot water. Now, you can probably put a pretty good guess as to which one of these two you think is going to win. But as a good scientist, we have to test all possibilities. So I'm going to use the same amount of water, 2 tablespoons worth. I'm going to pour it onto each one. So I'm going to pour cold or room temperature water onto this one here and then hot water onto that one there. So we're going to go ahead and pour our cold water onto this ice cube. You can hear it cracking a little bit because even room temperature water is warm enough to warm it up a little bit. And you can see it started to cause a little divot in there as well. Now, if we do the same thing with our hot water, see it's even steaming a little bit maybe. And we pour that same amount of water onto an ice cube. Ooh, get some cool little cracks in that one. And so you can see we have a smooth top on this one now. And that's because the hot water made that ice turn liquid really, really quickly. And so the surface becomes flat and smooth because of that. You can see the one we poured cold water on is still not like smooth. There's still divots and things like that because it didn't do that same effect. So, as you probably predicted, in this experiment, in this part of this experiment, the hot water outperforms cold water. And it's because hot water has a lot more energy in it. So extra energy in the hot water gets transferred into our little ice cube here. And that transfer of energy makes those water molecules that are now ice, it makes them move faster. And as they move faster, you start to see those cracks that happen and you start to see melting, because as material gets more heat or energy, it starts to move faster, and when things move faster, they go from being a solid to a liquid. Now that we've finished with the water experiment, we're going to move on to the second part of the experiment, which is we're going to test between two different solids that if we add them to ice, will they change how they melt? And so the two solids we're going to be using today are table salt, one of the experiments, and the other one we're going to compare it against is sugar. Alright, so we're going to take these and open these up. You can probably cut because I don't know how the heck this is tied. What is going on? It's too much for me. Oh, okay. Who did this? I don't understand. Okay. So, we're going to test between the sugar and the salt. Where did I put my, here it is. Make sure this is dry. We're going to get about 2 tablespoons of sugar, roughly, right? We're going to pour it onto the top and try and keep as much on as we can. It's not all going to stay on. And now we're going to really quickly try and get the salt one to do the same so we can have them be about the same time. So what we're looking for is if it happens to make it melt faster. So now we're going to do the same thing with our salt. And we're going to let it run for a little bit and see if we notice anything change on either one. Alright, so you can see the difference between... Oh, sorry Steve, I'll put you up here. So, you can see the difference between these two ice cubes now. The one with the sugar didn't really melt any faster than if you just had a block of ice there. Sugar doesn't really interact with ice in any way that makes it melt faster or slower. But salt, on the other hand, does. If you notice, the salt is actually wet all around the ice cube because it is melting the ice cube. So the reason salt melts ice, you may know that they put salt out on the streets in the wintertime to help melt ice off the streets. The reason salt does this is because what salt does when it gets added to water is it lowers its freezing point. So you may know from school that water freezes at 32 degrees Fahrenheit, right? Well, when you add salt to it, now it has to be about 4 degrees colder for it to freeze. And so, if this ice is 32 degrees, and I add salt, now it has to be 28 degrees in order to stay frozen. And since this ice doesn't have a way of getting colder, it is going to melt, because now it's 32 degrees but needs to be 28 in order to stay frozen. So that is why we add salt to ice to make it melt. You may put it on sidewalks, roads, whatever, because it makes the ice have to be colder, and that's really hard for ice and snow to do when it's already only needs to be 32 degrees to be frozen. And so you can see the difference between the two as to how they're slow. One's melting the one ice cube, and the sugar is not doing anything to it. Alright, so we know that salt helps us melt ice and heat helps us melt ice in the hot water. But there's one other thing that we can use to melt water, and that is weight or pressure. Now, there's a lot of times where like the sidewalk will be icy, but it's only when you step on it that it really gets slippery because we put weight on it, and so it melts that ice a little bit. And I'm going to show you that hopefully with this experiment. So I have this thing that I have no idea what it is, but it's very heavy, and so we're going to use it as our heavy weight on one of these two new blocks of ice, and the other one's not going to have any weight on it, and we're going to see if one melts more than the other. Now I may have to hold it on because I don't know if these ice cubes are very flat, but we'll do our best. So we're going to take our weight and put it onto our ice cube. So you can see this ice cube here did not have this on it. This one did, and it's about half the size in a giant pool of water now because the weight alone melted that. So the idea behind this is the same thing as to why ice is slippery in the winter. Even if it's like 10 degrees outside, well below where ice should be solid, when we step on ice, we're putting weight on that ice. And when we put our weight on that ice, we do the same thing that happens here. So even though it's the same temperature in this room as this side, this one melts because of that weight. And so when you step on ice, you melt a little bit of that ice, and then you get a very thin layer of water in between your foot and the ice. And that's what actually makes ice slippery. If you could touch ice without melting it, ice is actually not that slippery. It's kind of like if you've ever had the chance to mess around with dry ice. Dry ice is not slippery, and that's because when it melts, it does something called sublimation. So it doesn't actually turn into a liquid, so you never get that liquid layer. It goes straight into a gas. Quick disclaimer, don't touch dry ice. That was just an example. Don't do it. And so this is the most efficient way we've done in our experiment to melt ice, is to put weight on it. And so now you know kind of why, even when it's super cold and ice shouldn't be wet, why it gets slippery. Alright Steve, so we're here to our next experiment. We're going to take this water, and instead of melting ice into water, in this one what we're going to try to do is turn our water into ice. Now if you've made ice at home, you know the quickest and easiest way is to put this in the freezer, right? That's the way you make ice at home. But I'm not at home, I'm at a place that allows me to have liquid nitrogen. So I'm gonna put one of these into our freezer in the other room, and we're gonna put the other one into liquid nitrogen, and we're gonna see which one freezes faster. And we'll talk a little bit about why after. Okay, so here's our freezer. We're gonna go ahead and just throw this in here behind the cookies. And we're gonna leave it in there and see how long that takes to freeze. And we'll come back and we'll check on it in a little bit. Okay, so we have our one in the freezer, and now we have our other one here, and we're gonna put some liquid nitrogen into this cup. Excuse me, Steve. Now you can see it boiling, or looking like it's boiling. And it may look like it's boiling because that's exactly what it's doing. But unlike water, which boils at 212 degrees Fahrenheit, liquid nitrogen boils at negative 230 degrees Fahrenheit. So this is very cold. So this steam you see coming off is a lot like steam from boiling water, except you may notice that when you boil water, that steam goes up into the air because warm things tend to rise. Whereas this steam, as it comes out of the cup, goes down because it's very cold. I'm gonna have to add a little bit more. Water has a high specific heat, so it actually takes a lot of liquid nitrogen to freeze water. Alright, so it's been a few minutes. We're gonna go ahead and pull this out. And if we turn it upside down, we have no liquid running to the bottom. And that is because we have now a test tube filled with ice. Let's go ahead and check on our freezer one and see how it's doing. Okay, so we started this one first and we're taking it out second. So it's actually had longer, and we still have just liquid water. Not even that cold yet. And so you can see that liquid nitrogen gets so much colder that it can freeze water in about, I think that was about 3 or 4 minutes. You can get frozen water instead of just slightly cold water. Alright, so that is our cold experiments for today. I think we ended with a pretty good one there. Now we have a little bit of liquid nitrogen in here. Hopefully we haven't broken the cup. And we're gonna go ahead and let you guys go. Hopefully you enjoyed the experiments today. I know Steve and I enjoyed having you here for our experiments. And we're gonna do one last thing here. Just a fun little thing to say goodbye. All right, see you guys later.